So let's talk about dilations. Dilations are not rigid motions. The goal is to really make something bigger or smaller. So like in reflection, translation, rotation, everything had to stay the exact same size. You just flipped it or slid it or rotated it. The goal for this is really to make something bigger or smaller. So you're often given what point you're going to dilate from. For this example, I've got ABC drawn here. You should take out a piece of paper, pause the video, and plot ABC. And we're going to do a dilation Let's do a scale factor of 2 about the point. Let's pick a point like -1,4. So that would be given to you already. And you actually would want to plot the point -1,4 on your graph. Now, -1,4 is like right here. I'm going to actually put like a star at it, because I don't want you to think that this is anything that we're going to connect to. What a dilation is that you're going to double the distance. Since your scale factor is 2, that means we're going to double the distance from the starred point to each point. So for example, take a look at A. If you look at the star, to get from the star to A, you go 1 space down. To double the distance, you would go 2 spaces down. If you look at B, you would go 1, 2, 3, 4 spaces to the right. You double the distance, you would want to go 1, 2, 3, 4, 5, 6, 7, 8 to the right. And C, if it's down 1, 2, 3, over 1, 2, 3, you want to double that distance. So we want to go down another 1, 2, 3, over another 1, 2, 3. And remember what I was saying, the goal is to double the distance between the star and each point. And we're actually going to make a figure that looks similar, but actually is bigger because we were doubling it. We could also make it smaller as well. Let's try another dilation. You could take a minute, plot these 3 points. We're going to dilate with a scale factor of 1/2. And let's dilate from the point F, which is 5, 1. So like we were doing before, at the point 5, 1, we're going to put a star. And so if we're doing half, we want to be half the distance from the star to each point. So if it's 4 spaces to get to D to the left, then we would want to go halfway, only 2 spaces to the left. If it's up 4 over 2 to get from F to E, we want to go up halfway and over halfway to get to where E would belong. And the goal would be that we have a similar shape. So we're talking about this triangle in here. But when we multiply by half all these distances, we are actually getting a smaller shape. So anything that is smaller than 1 for a scale factor, the figure is going to get smaller. If it's bigger than 1, it's going to get bigger.